Welcome back, welcome back, welcome back to science. All right, we're going to talk about paths of circulation today. We're going to look at specifically the pulmonary circuit and systemic circuit because this is where our blood is ultimately flowing. With the pulmonary circuit, the main goal here is to have oxygenated blood return to the heart. We're going to send deoxygenated blood to the lungs and back to the heart. It's going to be oxygenated blood, but let's go through the actual vessels of how that's happening. Once again, we started with our deoxygenated blood that's emptying from our coronary sinus, our superior vena cava and inferior vena cava, into our right atrium. And once it's in the right atrium, it's going to go through our tricuspid valve into our right ventricle. Now that we're in our right ventricle, that ventricular contraction is going to send it up through the semilunar valves of the pulmonary trunk. So here, now that we get into our pulmonary trunk, it's going to quickly fork off and go into the left and right pulmonary arteries. Once again, this is deoxygenated blood in an artery, the only arteries in the body that's carrying deoxygenated blood. It's going, arteries are away, and it's moving towards our lungs. Once it reaches our lungs, it's going to reach something called the lobar branches. There's going to be a bunch of different lobar branches. Whenever you look at this, it's going to have a tree-like look. Then it's going to move to our pulmonaries once it's been through all of our different branches and forks. It's going to go to the pulmonary arterioles, then our alveolar capillaries. This is an important step. At the alveolar capillaries, this is where gas exchange is going to occur at the alveoli of the lungs. We're going to look at that in just a minute and really look at the details of it. Once we have our oxygenated blood, it's going to empty into our pulmonary venules, then our pulmonary veins, and that's going to lead to the left and right pulmonary veins emptying into the left atrium. At the left atrium, blood is then going to go from left atrium into the left ventricle, where you're going to have contraction. At that contraction, it's going to then enter the systemic circuit. So blood in the pulmonary veins and venules and veins are going to be rich in O2, while blood that's going to be in the pulmonary arteries are going to be pretty low in O2 and high in CO2. So let's get to the systemic circuit. Systemic circuit is referring to the systems of the body. So this is leaving the left ventricle by contraction. It's going to go to the semilunar valves of the aorta. And then once it's in the aorta, you're going to have then all the different arteries and arterioles taking care of the body tissue, and then your capillary beds. And then you're going to have the systemic venules that are picking up that deoxygenated blood and then continuing further into the major pathways of the systemic veins and then emptying into your right atrium. So let's take a look at the alveolar wall. When we look at the respiratory system, we'll really dissect out with more specificity what's going on here. But let's take a look at our blood flow. Once again, this is pulmonary. We're at a capillary bed. And so this is a pulmonary capillary, blood flow in, deoxygenated blood. Notice that we have more structures on the outside than inside. So we're going to have a net flow of things moving out of our blood vessel. And so this is going to help in removal of things like carbon dioxide. It's going to have a net movement out because there's going from a lower concentration to a higher concentration. From higher concentration to lower concentration, you're going to have the diffusion of the carbon dioxide into the outside area, outside of that, in this interstitial fluid that's around. This interstitial fluid is also going to be an important part of drawing those blood gases, the gases from the alveoli into this area, and any bit of water as well, because of the colloids osmotic pressure that's going to be here. It's going to draw things into it. And once it's into this area, this fluid, then it can have the exchange with that pulmonary capillary as it's having CO2 that's leaving and oxygen that's entering. You see a little bit of lymph that's going to be picked up here as well with that interstitial fluid. And eventually you're going to have the blood's going to be oxygenated because you're going to have the diffusion of oxygen into this capillary. The carbon dioxide has exited. The interstitial fluid has left through the lymph. And now we're moving back going back to the heart side of things, leading to the left atrium. All right. We're going to look at each one of these in subsections, but these are the major vessels of the arterial system. And we can see major blood vessels of the heart. So let's run through those really quick. Ones that we've talked about a lot. We see the superior vena cava, aorta, pulmonary trunk, left pulmonary artery, right pulmonary artery, because it's a continuation off this. If we cut these out right here, you would see that just continuing on there. All right, if you go on the aorta, this is the arch of the aorta. This is ligamentum arteriosum, which we've already seen and discussed. We have three major branches coming off the top of the heart. So here's one. This is the brachiocephalic trunk. The brachiocephalic trunk, once again, this is on the right-ish side of the heart. The brachiocephalic trunk will have two different subbranches coming off that. One is going to be the right common carotid, and one is going to be the right subclavian artery. Clavian refers to clavicle. Sub means below. So this is going to run below the clavicle, and this is going to run up to the arm. We will get to those steps later. And here is the right common carotid. We're going to have a branch that's going to eventually have different feeds off of this, being the external and internal carotids. And we'll look at that when we look at vessels of the head. If we go over here, we have the left common carotid and we have the left subclavian. And you're like, wait, what? That's right. So you would think that the system would be perfectly matching on each side. It's just not. Um, and so if there's a single vessel that would come up, it would then go to the right and left like this one does with the common carotid and the subclavian. But these are going to branch off further. If you look at something like a pig's heart, pig is going to have four branches off of its aorta, which are going to be the right subclavian, the right common carotid, the left common carotid, and the right subclavian. And you can see how the anatomy changes just a little bit with the aortic distribution there. All right, so this is the left pulmonary vein, and you can see the left atrium, the right left atrium is underneath, the auricle's on top. Here's the right auricle, and you can see these different structures that we're identifying. Now let's look at the venous supply of things. So this is going to be the superior vena cava, emptying into the right atrium. If you go, there are two different branches of that. This major forked branch right here, this is going to be the brachiocephalic vein. And if you go off of that, you have a structure that's going to be on right with the carotid, and that's going to be the right internal jugular vein. If you have a branch that's going to be going off, this is the right subclavian vein. That's going to run right there with the right subclavian artery. Similar on the other side with our left internal jugular vein. And here we have our left subclavian vein. All right, so that's going to contain it on the vessels, just an overview there. All right, guys, I'll talk to you soon.